the best here?
Yeah, maybe start by doing a couple, like working them out, like you working them out, and then.
Okay, good enough. So product rule is d dx of u times v, and it's u v prime plus v u prime. Here, though, you have chain rule parts. So when you keep the first and take the derivative of the second, there is no chain rule here. You just take the derivative of this thing inside here. So it's minus x to the minus 2 plus 0 plus, and then the derivative of the first, so that's 2x minus 0 times x to the minus 1 plus 1. And the AP isn't great about simplifying on the free response. On the multiple choice, you do have to kind of look for those things. So it just in terms of like how, like what I think you might see on the exam, they would actually probably write it like this, and then they would actually probably also distribute into both of these. So
Okay.
it would look a little odd. This first one would become minus 1 because you're distributing it to that, plus 2 over x squared. And then here, it would look like this 2 plus 2x, okay? And then that, you would combine like terms here. So your final answer might look something like 2 over x squared plus 2x plus 1, maybe.
Okay.
And I think that's where a lot of students would struggle on the AP. They get to the multiple choice and think, oh, no big deal, but they present the answers differently than when you work them out. So, but do you remember the product rule? I mean, we've been doing, we haven't done it in a while, but okay. So why don't you try, this one's a much easier product rule problem.
Okay.
If you can simplify it if you want, but why don't you
all right,
work that one out, please?
So do you want me to simplify it or just keep it as like the?
Why don't you try simplifying it, because that probably is how it would be presented.
Okay. If you're multiplying the exponents, you add them, right?
Yes.
Okay. Okay, I got something.
Okay, let me work this out here. So I got this. My preference is to keep the first derivative of the second plus 2x and then x cubed plus 1. So it would look like 3x to the fourth plus 3x squared plus 2x to the fourth plus 1. So that gives you a 5x to the fourth plus 3x.
Wait, isn't it plus 2x?
Yes, plus 2x. Thank you. Plus 2x. Yes.
Yep, that's what I got.
Something like that. Okay. Now the real kind of one that you're going to see potentially if you get just a true product rule like this is they're gonna include chain rule parts of it. So it's going to look something like this. It'll be like x squared minus 1 to the power of 3 times 4x plus 5 to the power of 2.
Okay.
So when you take the derivative here, I'm gonna keep the first as is x squared minus 1 cubed. The derivative of the second, you treat it like it's a u squared. This is a reminder here. So it's 2, keep the inside, but then you have to multiply by the derivative of the inside, which is 4.
Okay, and then you do the
same. You keep the second, but then you got to take the derivative of this thing on the left here. So it's
2x.
3. it's power rule on the outside. You got, you treat it like a u cubed. Bring the 3 down, 3 over here, x squared minus 1, keep the
Oh,
inside, times 2x.
okay.
And then we should just do a tiny bit of just, at least in this problem, like from here, because this is not how the answer be presented. So they would for sure take the 2 and 8, multiply them together. So let me just kind of leave it in an unfactored form for the moment. And then you get 4x plus 5 squared. 3 and 2x gives you 6x. And then you would have this x squared minus 1 squared. So like what I'm trying to, like what they might do at this point is they might say, well, what do you have that's common to both terms? So in both you have between 8 and 6, you can factor out a 2.
Okay.
Between x squared minus 1 cubed and x squared minus 1 squared, you have an x squared and minus 1 squared. Yep.
Yeah.
And then you get 4x plus 5. Okay, so for me, it's very easy to see like, well, that's pretty reasonable here. You got 4 times x squared minus 1 plus you got 3x here. You got 4x plus 5 here, like this.
Yeah.
And then this gives you 4x squared minus 4 plus 12x squared plus 15x, 16x squared plus 15x minus 4 there. And then I'm going to copy and paste. Like that. That's probably how the answer be presented.
Can that on the left not be simplified anymore?
You could FOIL and then multiply, but then so the question is like, where do you stop? And you
Right.
you have to literally look at the answer space and be like, well, what are they doing there?
Okay.
And make your decision. So I don't necessarily want you to do all this. I mean, you can if you want, but I'd like to give you a problem like this so you could try on your own, if that's okay.
Yep.
All right, so let me actually rewrite this quite a bit. We'll go h of x equals 2x cubed plus 1 squared, and then 3 minus 2x squared to the power of 4.
Okay. So keep the first. So you keep the first and then do derivative of the second, but then do you do for the chain rule part, which one do you use? I think you're muted.
I'm sorry, I thought I looked at the wrong thing. Let me start back here. This is u to the 4th, and so your derivative is 4u cubed u prime.
Uh-huh.
And I know there's the u's and v's, but just if you're just looking at just this part here, so that's 4 times 3 minus 2x squared cubed. U prime, derivative of this on the inside here, so that's minus 4x. And that you're keeping the first already times this, and then there's the plus, big plus, because you're going to now do the flip of it.
Okay, got it.
Okay, carry on with that one, please, if you can.
I just don't know how to simplify this.
Oh, don't worry about that because this is more extreme than you're going to see.
Okay, so I got 3 minus 2x squared to the fourth times 2 times 2x cubed plus 1 times 6x squared.
Yeah, that's perfect.
Okay.
They give you, when they really want you to simplify, they give you something that kind of always works out nicely to be able to work through.
Okay.
The last example you might want to work through on your own just to see how you might do it, but even this one feels too extreme to ask a student to, because the multiple choice is pretty quick. I mean, you go through it pretty fast.
Yeah, and I don't know if the quiz is gonna be multiple choice on Wednesday, but I don't know actually. He said it's gonna be like 30 questions, but like 15 of those are the derivative formulas. So it's only 15 chain rule problems.
Okay. So we should jump right into some chain rule, more specific chain rule stuff, because I'm not emphasizing it in this problem very much, but and then we'll need to do some quotient rule. But here's a problem. This is a chain rule problem. The instructions just say to determine the derivative of this. So the way that I would have you work through this is this is the outermost function, this e, and the derivative of e is itself. Then the next most outer function is the cosine. So the derivative of cosine is minus sine. The thing that I think it gets unclear is that you continue to keep the inside part. So in this case, the inside part is x squared. And then the
Multiply
last
by
thing,
2x,
I'm sorry?
and then you multiply by 2x, right?
Yes.
Okay, so this is not a product rule one then.
This is chain rule. We've kind of, I mean, product rule you've got done for now. So like we should now, if I just very slightly change the problem, if I go y equals sine e to the x squared, what is the outermost function on this one?
Sine, so
Sine. Derivative of sine is cosine. Keep the inside part. What's the derivative of e?
e to the x squared,
Yep, keep it, and then you keep going with
2x.
2x. Okay. And it doesn't seem that difficult, but for some reason, if I just throw in just one more little wrinkle here, this is what seems to trap students into undoing all the good work they've done. So if it's like 1 plus e to the sine of x cubed, but all to the power of 5, this is the outermost thing. This 5, this power or power rule. So you have to
Bring the 5 in front.
yeah, and then you keep all this. And you're like what? Like, yeah, you just keep writing it. Then and then if this was in person, I would say I would be covering up the 5, because now you're just looking at what's inside the brackets. Like you don't even care about the 5 anymore. It's like, what's the derivative of this thing inside the brackets? And
So just e sine.
yeah, you keep what is e sine x cubed, but then you've accounted for the e. So like sometimes students will like cross out things that they've dealt with. I don't really like that, but it does help you to navigate like what you've done and not done. So if it works, please do it. Now you got to deal with sine. What's the root of sine? It's cosine. Keep the inside.
And then times 3x.
3x squared. Yeah.
Yeah.
Okay. So let me give you some problems here and just see if you've got a good handle on this. So let's say it's sine of x squared minus cosine of e to the x all to the power of 3. And I'd like you to take the derivative of that, please.
So Okay, I think I got something.
All right, so the first thing is this power. So you bring it a 3, and then you keep all the inside stuff, which, well, it's a lot of rewriting. But now you just focus on the inside. So the derivative of sine, derivative of sine is cosine. Keep the x squared. Now, because you're still working on this, you do have to continue to take through like this minus operator is here, but if there's a derivative of the inside part, you have to keep taking that.
Okay,
I know I
that's
did.
that's what I did, and I was not sure if I did it right. So
Good. So now minus, what's the derivative of all this? Derivative of cosine is minus sine. So you could go plus sine e to the x times e to the x.
Okay, so I wasn't sure if you wrote e to the x twice either, but you did.
Because you continue carrying it through, like you're taking the derivative of all this.
Okay, that's what I thought. Okay, wow, I did it right.
All right, so that like the way, like another type of problem that you might see is like where they give you a bunch of nested things. They say like the natural log of let's go tangent of let's go e to the let's go cosine of x cubed. Okay. You want to give this one a try on your own?
Sure.
Okay.
Oh, ln 1 over x, right?
Yeah, du of 1 over u is, or natural log of u is 1 over u times the derivative of the inside function. I wrote that terrible. Natural log of x.
Okay, I really don't think I did this right, but I have an answer.
Yeah, well, the thing is you maybe you've gotta come up with some sort of like way you're gonna work your way through this, because you just start here and then you jump in, and so there's a lot of rewriting. Like all the inside stuff goes on the bottom here, and this is a super extreme example. You're not going to get a problem like this. Let me actually just make this a little bit tighter. Okay, now you take the derivative of tangent. What is the derivative of tangent?
Secant squared of x.
Secant squared of whatever's inside. So x refers to all the inside stuff.
Okay, that was my mistake.
Okay, and then, like I said, some students they kind of say, okay, I've dealt with that. I've dealt with that. Now, what's the derivative of e?
E to the cosine.
Keep it. Okay,
So then you do negative sine x cubed.
Yep.
And then times 3x squared.
Yes.
Okay, so I got all this stuff right. Just wrote it.
It has the appearance of being, really hard, but it's just a lot of like follow things like that you might see. So.
Okay, well, I didn't get it completely wrong then.
All right. We should either move to implicit derivatives or some quotient rule stuff. Do you have a preference?
maybe quotient rule first.
Sure. All right, so go back to, I found some really good problems. So just figure something like this. All right, so do you need a reminder of the quotient rule?
Yes.
Okay, so it's u over v, and it's the bottom times the root of the top minus the top times the root of the bottom over the bottom squared. And you're welcome to like come off to the side and actually actually like write out what u and v are, but I at this point in the course I'm just going to work it out without mapping them to the side. So the bottom function is 1 plus sine x, and then the derivative of the top function is 1 minus, and you probably don't get a formula sheet, but that minus is the kind of thing that you would see on the AP or a practice test, because they really want to make sure you know that. And then the top times the derivative of the bottom. The derivative of the bottom is cosine x over the bottom squared.
Okay, yeah, I remember this.
Okay, and then you could simplify. I don't think we did much of this, but some of them don't simplify very well, but some do. So this one does not, though. It's not not really all that helpful. So here's one I kind of like that. I'm going to point this out to you. This has the appearance of a quotient rule problem, but it is not. The reason it is not a quotient rule problem is you can actually use some exponent rules first before applying any derivatives. And I don't recall the AP having a lot of these in there, but maybe your instructor will consider one of them to introducing some of them, because this becomes -1 minus -3 x squared -2 minus a -3, which is x, and your derivative is now 2x plus 1. Whereas if you try to use quotient rule, it gets very messy very quickly.
Mhm.
So maybe like just pause before each question and see, like, is there a simplification that I'm not seeing here?
Okay.
All right, so back to like actual quotient rule problems. Let's say I ask you to find the derivative of 1 plus e to the x squared over sine cubed x. Okay, so I made this one intentionally more complicated because this one has chain rule inside of it.
Oh,
So
okay.
you take the bottom, right? The bottom function, whatever's in the bottom, you just bring it up. Okay. Now you got to take the derivative of this thing up top. So the derivative starts with this power. It's 2 times 1 plus e to the x power of 1. But then you have to take the derivative of the inside, which is e to the x minus, keep the top. And then this one maybe you haven't seen in a while. The way this is actually written is it's sine x to the power of 3. So it is also kind of a 3 sine x squared, and then you take the derivative of the inside function
Okay.
all over.
So it's like a bunch of chain rules within.
Yes, and then I'll make one easier here for you to do next, but that's the kind of thing you're looking for, is like things that could trap you because you haven't seen in a while. You don't remember. Oh yeah, it's really sine x cubed. Okay, so let's have you try. I'll have you try it. It's a little bit nicer, but let's go with 1 plus x squared cubed over. Let's just go with cosine squared x. Why don't you give this one a try, please?
Okay.
Right. Is it okay if I just work this one out so you can see
Yeah.
the steps? All right. So the derivative starts with the bottom function cosine squared x, and then the derivative of the top function is 3. Keep the inside part, power rule, so you just make that a 2. And then you have to take the derivative of the inside function, which is 2x, minus, keep the top as is. The derivative of the bottom is 2 cosine x, and then you take the derivative of cosine x, which is minus sine x, all over the bottom squared.
Okay, I had everything right. I just flipped the top. Like I did keep the first.
Okay. On a multiple choice exam, that would definitely be there. So.
So bottom first. Okay.
Yeah, and so actually, I guess we didn't cover that. I actually don't remember the formula. Like if I woke up like 3 months from now, I hadn't done so, I would still remember bottom top prime minus top bottom
Okay.
prime, because they like those mean more to me than using U and V. Because I used to get confused. I had to remember that U is always on top because it comes before V.
Oh, yeah.
So
Okay.
just briefly here, do you see that there's a cosine X in both places?
Yes.
Both at the top. So they would actually factor one of those cosine X's out. All right. And it would cancel with one of them on the bottom. So see how you have 4 on the bottom here, you would have cosine to the 4th X on the bottom. And that's how, that's one way that you might see this simplified. You have 6x here.
Wait. How do you get to the fourth? Like
You have squared.
it doesn't, if you have a cosine, aren't you like multiplying by cosine? The whole thing by a cosine squared x. So then that extra 2 comes, it gets.
So just to be clear, like what's on the bottom here is really cosine X squared, and then you're squaring that. And that's why it becomes cosine
Right. So are you
X.
taking a cosine? Are you factoring out a cosine squared x?
No, just one cosine from, I was attempting to maybe show you how this might be simplified. I was taking a cosine out of those two.
Oh,
And I
out of
was,
the top
yeah,
two.
I'm sorry.
Okay.
I was
Got it.
like, there's a lot that this does, but this is not a good example for us this is too complicated. It's because it takes too much time, and that's the big deal. They're going to give you lots of questions on it, but let me give you the last quotient rule that I think might be worth doing, because we haven't really talked about this derivative yet. So let's go 3 to the x over x plus natural log of square root of x. Actually, you don't need that here. So again, if you don't recall, the derivative of a to the x is itself times the natural log of a when you take the derivative of the top thing there. The bottom has some chain rule stuff going on in it, so just give that a careful look. But yeah, why don't you take another minute or two to work through that,
All
please.
right. Um, Okay, got something.
Okay. So you start with the bottom, x plus natural log square root of x times the root of the top, which is itself, you treat this kind of like an e, but the added little wrinkle is that you treat the natural log of the base.
Yep.
And that's why e to the x is e to the x, because the natural log of e is just 1, minus, keep the top, derivative of the bottom. So the derivative of x is 1. The derivative of natural log is 1 over whatever's inside there. And then you have to take the derivative of the square root of x. Square root of x is really x to the 1/2. So it becomes 1/2 x to the minus 1/2 power, like that.
Wait, are you doing 1 over root x all raised to that power?
No, let me get the right position here. So it'd be 1/2, and then x to the minus 1/2 is here in the top.
I just didn't know what the derivative of root x was. That's the only thing I got wrong there.
Well, this is kind of interesting or important. The x to the minus 1/2 actually goes to the bottom, and it combines with this one right here on the left to make just x, because it's square root of x, and then there's a square root of x here. So everything in parentheses here becomes 1 plus 1 over 2x, like this, like that.
Oh, and that's how, okay.
That's how it would appear in some sort of a thing.
Okay, so just got that.
Yeah.
All right.
Let me pull up another problem, but I don't want us to do it, but I want to just like make a comment here, because there's so many of these, like I couldn't tell you all of them that you might be asked to do, but this one you have a choice. You can actually foil this before you start, which makes the derivative easier.
Okay.
And so generally, when you can apply some algebraic concept, you should do that. And here's what you're looking out for, like exponent rules, simplifying, which is kind of exponent rules, foiling is one of them. And I'm sure there's a couple others here that I'm not thinking about, but if you don't foil, when you take the derivative of the bottom, what rule do you have to use for the derivative of the bottom?
Product rule.
Product rule. And it just adds more complexity.
Right. Okay. So
Something like that. No.
Okay.
Let me show you this next problem here, because I would like to use the last 10 minutes for implicit derivatives, but I just want to make a few more comments here. Okay. Here's 7, but here's a problem like 7 on the right here. The one on the right here, you would simplify. You would actually make this x cubed over square root of x plus 1 over square root of x. Meaning you would use these exponent rules, but on the left you have to use quotient rule.
Okay.
And that's because there's one term on the bottom. That's why you can do that.
So, oh well, we're not going to do that one, right?
No, I don't think so. So I was going to move to implicit derivatives, unless there's any other things that you would like to try.
Is the implicit derivatives like different than chain rule, or can there be like chain rule within implicit derivatives? Okay.
Yes. So something would be, here's the kind of the basic.
Wait, so implicit derivatives, what's the u sub? Oh, that's just called u substitution, right?
Never yes. So this is an implicit derivative. The way you take derivatives with respect to x is the same as always. So this is 2x, but and we should do the y first. Let me actually reorganize this slightly so that we can do it in the order that's easiest to understand. When you take the derivative with respect to y, it's just like x, except you add this y prime.
Oh, right. Okay.
That goes along with it.
I remember this, yeah.
And so where it gets complicated is like, well, this right here is a product rule.
Right.
So it's keep the first, derivative of the second. The derivative of y is y prime plus y and then derivative of 1.
Okay.
And then from here, you have to solve for y prime.
Right. So then you.
So you move any non-y terms to the other side of the equation.
Okay.
So this equals minus 2x minus y. And then
Wait, I thought you said any non-y prime.
Y prime, yeah. And then you always factor out
the y prime.
Y prime.
Oh yeah, I remember these. I liked these actually.
Yeah, they're
Then you divide by the 2.
divide.
Yeah.
Now this one, I didn't pick a very good one, but we chose to put like minus 2x in front of minus y. Like when I subtracted that in the earlier line, like I made a decision to put that, but this is equivalent to minus y minus 2x over 2y plus x, meaning just change the order. And if you factor out a -1 out of both in the top and just put it in front of the parentheses, it becomes 2x plus y over 2y plus x with a negative out in front. And
that, nah.
Well, because it's multiple choice, and if you've seen any of my question of the weeks, like I had to deal with this in one of the problems. You can organize answers that, like these are all the same, but you know, 3 different people will give you 3 different answers. And you need to know that these are all the same. So like if you get this one, but the answer shows this one, you need to be like, oh yeah, that's it.
Got it.
All right, so let me give you one that's about the same difficulty before we move to a different type. Let's go 2x cubed y minus y squared plus 1 equals x.
Okay. So you just start by factoring 6x. Would it be 6x squared y prime, or would it just be 6x squared y prime?
So did you already take are you talking about the second term? Like, did you already keep the first, take the derivative of y?
Oh, I did this wrong.
Okay, why don't you give it one more look?
Yeah, okay, that's what I got. So now
Okay,
you
perfect.
move the 6x squared y over, right?
Yep. Mm-hmm. So it's 1 minus 6x squared y.
Cubed y prime minus 2y prime. Take out the y prime. So then it's y prime equals 1 over. Yeah.
All right, great. So again, like they could switch the order really of anything. I mean, they wouldn't like try to do that, but that's just something to look out for.
Okay.
So, all right. So just another type of like implicit derivative that you might see would be something like this. It would be like sine xy plus natural log x over y equals, I'm just going to put an x here just in case. So I'll work this out with you. On the left, you start by taking the derivative of the outside function. So the derivative of cosine is cosine. But then you have to take the derivative of the inside function. The inside function is a product rule. So that's xy prime plus y.
Wait, so cosine. Okay, yeah.
Okay. This one, there's two ways to do it. I'm gonna do it the way we would see here. Normally it's 1 over x over y, but then you have to take the derivative of
X over y.
x over y. So it becomes bottom times root of the top minus the top times root of the bottom over the bottom squared
Yeah.
equals 1. So we are not going to solve this for y prime, but this is like maybe just one of these equals x could be one that you might do. In fact, let me just do that. Let's just say it was sine xy equals x, and work through that part just as I guess a reminder here. So this would equal 1, and you're still trying to solve for y prime. So you just undo stuff. You would undo this cosine xy.
You mean like an antiderivative?
No, you divide.
Oh, gotcha. Okay.
Divide, yeah. Okay, now 1 over cosine is really secant, so you might see the answer written like that. So you may want to review your trig. This.
Yeah, those are going to be on there, I think, too. So. And then you just divide by x.
Yes. So your y prime equals secant xy minus y over x. We did not do any tangent lines. We didn't do any sort of related rates, which are derivative based. So maybe in preparation for tomorrow, see if there's other types of problems you'd like to.
Yeah, I'll ask him like specifically what kind of chain rule stuff is going to be on there today, tomorrow.
All right, excellent. Well, thanks so much for scheduling. I'll send you the notes here shortly, and I'll see you tomorrow.
Yeah, bye.
Have a great night. Bye now.